So for week 2, we're going to be focusing in on the practices of science, and then we'll be using science learning to do some engineering design in week 3. So this week is all about science. And the lessons that we're going to do come from a curriculum called Save the Penguins, which is a part of an engineering teaching kit website. So I will, during week 3, load up all the materials. So if this is something you're interested in using in your classroom, you'll see the whole suite of lessons. I'm just pulling a few of those lessons for us to take a look at STEM activities for this week. The way you're going to turn in your science learning is using what's called a storyboard. You can see an example of one here that was created by some students in my class last year. Each group gives themselves a name. This group decided to be the Kool-Aid Power Rangers, so that's what that's about at the top there. And you can see that there's 9 panels on here. You're going to also be making 9 panels. There'll be slightly different things that you'll be putting into your panels. But so this is on one of those large 3M Post-its or a large piece of butcher paper is how we do them in the classroom, so students can display them up on the walls of the classroom. You can do each panel on a separate sheet of paper. However is easiest for you to do that. You're probably going to have to take pictures of them to be able to turn them in. But it's a lot easier to try and draw these by hand than it is to try and do them electronically on the computer. Although maybe you're more skilled than I am, I don't know. I certainly don't know how to do that. So the science we're going to be looking at is heat transfer, and this was designed for a 6th grade level. I've done it with kids as young as 4th grade, and I've also done it with high school kids in like 9th grade physical science. So it works very well at different levels. Obviously the depth of concepts you go into would depend on the age of kids. So the first, it's a series of demos. So I'm going to talk you through, and you're going to do the demos for yourself, either in your classroom or they're all perfectly safe to do at your kitchen counter. So the first one, the challenge is you want to bring a cold soda on a field trip and be able to have it still be reasonably cold at lunch so you can enjoy it. So the challenge is to decide what is the best material to wrap your soda in. So when you leave the house, you're going to wrap it, and then 3-4 hours later, be ready to drink your cold soda. So the choice of materials you have are aluminum foil, a cotton sock, paper towel, plastic wrap, wool sock, or just leave the can as is, leave it naked. So those are your choices. And what I'm going to ask you to do on the next slide is to discuss your prediction and explain your prediction. So on the first panel, I'm going to have you think about just the soda can. Why does the soda can heat up after you take it out of the refrigerator? Use words and pictures to explain what's going on. Why does that soda can heat up? And then on the second panel, based on your prediction, which material will work best to keep your soda cold? So tell me what you think is going to work best and explain why you think that is the best material for keeping your soda cold. You probably want to pause the video right now and fill out those 2 panels, and when you're ready, return and hit play. So hopefully you've got the first 2 panels done and you're not cheating ahead on your prediction. So now you're going to go ahead and do the demo. So you're going to need to take all of your 6 sodas out of your refrigerator. You want to handle them as little as possible and do this as quickly as you can, but obviously it's going to take a little bit of time and some will be unwrapped a little bit longer than others. So having your materials ready ahead of time is going to obviously make that go a little quicker. So you're going to prepare the materials. You can see a picture at the top there. About 3 wraps around with the plastic, the paper towel, and the aluminum foil. You want to try and make sure the top and the bottom of the cans are covered as well. 1 you're going to leave naked, and then 2 you can see the can is kind of shoved down into the sock. This is where if you weren't able to get a wool sock, you'll have 5 cans instead of 6. Just let them sit out on the counter for about 3 hours. 2 hours is probably the minimum. If they're out for 4 hours, probably okay. You probably don't want to go over 4. And don't leave them sitting in the sun. So you could just shove them in a cabinet or put them somewhere on the table if it's in the shade. After those 3 hours, you're going to unwrap, or you can just peel the top, pop the soda can lid, and take the temperature of the soda. You're going to want to record that data, obviously. When you're using your thermometer, make sure that the thermometer is not touching the sides or the bottom of the can. You want it to be hanging directly into the liquid. So about halfway down, make sure that the tip of the thermometer is in the liquid and not touching the sides of the can. Once you have your data recorded, you're going to be ready to do your next panel. So on panel 3, you're going to share your data, tell us which materials work best, and explain why you think those materials work the best to keep the can cold. Make sure you include your new vocabulary words: heat transfer, temperature, insulator. And make sure that you show the direction of heat transfer. So where is heat coming from and going to as you think about what's going on with the cans. Again, you're probably going to want to pause the video here and take some time to work on your panel and then come back for the next part of the demo. So we've looked generally at heat transfer with the aluminum can activity, and now we're going to dig more deeply into 3 specific kinds of heat transfer. We're going to look at conduction, convection, and radiation. We're going to start with conduction, and I can see I've got lots of fun little animations here. So what you're going to need for this activity is your plastic spoon, a metal spoon, and 2 ice cubes. What you're going to be doing, you can see in the picture there on the left, is you're going to be putting an ice cube onto each of the spoons, holding the spoons, and just waiting for a few minutes to see what happens. What I'd like you to do first, before you actually go ahead and do that, is your 4th panel. I'd like you to predict which spoon you think will do the best job to keep the ice cube cold and explain your prediction. So again, pause the video before you go ahead and do the demo. So now you've got your prediction, you can go ahead and actually do the experiment. So just as it shows in the picture, go ahead, hold those spoons, and make careful observations of the ice cubes that are in each of the wells of the spoon. And you're going to want to take some notes on that to include in your 5th panel. I also added here, this is a point where if we were in a regular face-to-face classroom, we would stop and do sort of a small mini lesson on what's happening with conduction. So you'll see a YouTube video there that'll give you some of the sort of background science about conduction to help you get a better understanding of what you're observing there. So in your 5th panel, you're going to talk about which spoon kept the ice cold the longest. You're going to explain your observations using pictures of words and use your vocabulary words, heat transfer and conduction. And again, it's important to show the direction of heat transfer. So where's the heat coming from and going to? So again, pause, take some time on your panel, and then we'll be moving on to convection. So for your convection storyboard, what you're going to need here is your large container. This would work okay if you have a large Pyrex casserole dish. It's going to be a lot better if you have a large plastic storage tub. And you're going to want to have that container filled up with room temperature water, probably about halfway filled. If you've got a large tub, there's no need to fill it to the top and have a very heavy, unmanageable volume of water sitting out on your kitchen counter. So get your container of room temperature water ready. You should have pre-made some ice cubes, so you're going to need your blue ice cube that you prepared ahead of time. And you'll need your small glass bottle, and in your small glass bottle you want to have hot water with some red food dye in it. Don't have it hot to the point of boiling, because you're going to want to put ultimately you're going to be putting your finger on the top of the glass container so you can submerge it down into the tub and then release it. So don't have it so it's too hot and you're gonna hurt your thumb. So hot water out of the tap should work just fine here. No need to be boiling anything. So before you go ahead and actually do that, if you've got your materials ready, take some time on panel 6. Predict what you think is going to happen. So you're going to have a blue ice cube and hot red water that's going into this container. What do you think is going to happen, and why do you think it's going to happen? Again, hit pause, take some time on that panel, and then we'll come back and actually do the experiment. Okay, so here we go. So you're going to go ahead and actually do the demo at this point. If you're having a hard time following my directions, I'll repeat them one more time, and then there's also a YouTube video link there that'll help you figure out what's going on there. The first part of the video, you'll see the students actually preparing their food dye, so you can, it's only about 45 seconds, so you can either fast forward or watch that. But so you've got your plastic container with room temperature water, and you are going to submerge your blue ice cube, the container with the hot red food dye, submerge them both down into the bottom of the plastic tub of water and let go, and you're just going to observe for a few moments. It's probably 3 or 4 minutes is probably good. And then on your 4th panel, you're going to explain your observations using pictures and words again. Include your new vocabulary words, so heat transfer and convection. And again, make sure you show what's happening with the heat transfer. What direction is the heat moving during this demo? So again, you're going to want to pause, take some time, work on that panel before we come back. And then I've got a link here again If it was face-to-face, we could sit and talk about convection, do a little mini lesson. There's a YouTube link here on convection that you can use to get a better understanding of what you just observed if you need some help with that. Okay, on to radiation, our third form of heat transfer. This is a pretty simple demo. You're going to need a heat lamp or a desk lamp, doesn't matter what you have, and your Mylar sheet, your emergency blanket. You're going to turn on the lamp and you're going to hold your hand directly under the lamp. You don't want to burn yourself, so kind of gauge roughly a foot away so your hand's nice and warm, and then you can cover your hand with the Mylar blanket and just observe what happens. There'll be more feeling than not observing your own eyes. You're gonna feel what's happening on your hand. The YouTube link there is a demo of Dr. Chris Schnittke, who's actually the person who designed this curriculum, demoing that, so that'll also give you a sense as to what that looks like and how she does that in her classroom. So on your last panel, you are going to, again, explain your observations with pictures and words and use your vocabulary words of heat transfer and radiation. And again, make sure you show what's the direction of heat. Where's the heat coming from, going to? And again, there is a little YouTube link there to talk about radiation and how heat is transferred during radiation, just to kind of boost some of your science learning there as necessary, depending on your science background. It's going to depend how much you need to use that. So you're probably going to want to hit pause, do that 8th panel. We've got one more panel to go. Okay, last but not least, panel 9 is going to be a summary of our learning about heat transfer. And so in your last panel, use pictures and words to compare and contrast all three forms of heat transfer. So you're going to look at conduction, convection, radiation. How are they similar? How are they dissimilar? There's a little YouTube link there that'll help you summarize some of the science behind those three forms of heat transfer that you can use to help you as you wish with making your last panel. And then the last thing you're going to need to do is to turn in your storyboard. So you have 9 panels at this point, either on a very large piece of paper or on 9 separate pieces of paper. Probably the best way to go about doing this is to take a picture of each of the 9 panels that you will be turning in. You can either turn in like as JPEG files or whatever onto the Moodle site, or if you would prefer to turn in a link to those pictures, if you use Picasa or any such site, you're welcome to, or Dropbox, anything like that, you're welcome to share them with me that way, whatever is easiest for you to do. And that will be all of our science lessons for this week. I'm sure it's taken you a lot longer than the 13 minutes it's taken me to record this video, because there'll be lots of stopping and starting to do the experiments and make your panels. So next week we will be using our science learning to do an engineering design task. So be prepared for the same kind of format next week. You'll actually be doing, applying the science learning to an engineering design challenge. And then in week 4 we'll start to reflect back, thinking about the NGSS, practices of science and engineering, and what's going on pedagogically in terms of what you might be thinking about doing in your classroom. So that's where we're heading. And I will be getting a video up and everything you need to know for week 3. Talk soon.